Hey everyone, let's take a look at Achieve section 3.7, number 11. You're supposed to find the derivative of this function here. I'm going to do this for you two different ways. The first way is, I think, maybe an easier way, and that is to rewrite it and then use the product rule. You could just straight up use the quotient rule as well. I'll show you that. I think the problem comes maybe in simplifying that expression perhaps with the quotient rule. Either way, it's a little tricky, but let's do it anyway. X plus 1 to the 1/2 power divided by the quantity x plus 15 is the same as x plus 1 to the 1/2 power times the quantity x plus 15 to the -1 power. Remember that this means what? The reciprocal 1 over x to the 15th power. Okay, so be real clear, be careful to note that this is not the same thing as x to the -1 plus 15 to the -1. You can't distribute an exponent over a sum or a difference. That is incorrect. Same thing with this 1/2 power. All right. By the way, the 1/2 power would mean the same thing as the square root of the whole quantity x plus 1. Okay, so they're trapped inside, right? These parentheses are trapped inside. So I've got this function here, x plus 1 to the 1/2, and this function, x plus 5 to the -1. I'm going to use the product rule, right? So I take the derivative of to find the derivative of the function, the derivative of this first function times the second, plus the first one times the derivative of the second. Now, in the derivative of these two functions here, excuse me, those are going to be chain rules, although sort of baby chain rules, if you will. The inner function's x plus 1, bring the 1/2 down, x plus 1, subtract 1 from the power. That's the derivative of the outer function, right, which is u to the 1/2. Evaluate the inner times the derivative of the inner. Well, what's the derivative of x plus 1 with respect to x? It's just 1. Okay, so that's just going to be 1/2 x plus 1 to the -1/2. Here, very similar, we bring the -1 down in front, right? Derivative of the outer function, bring the -1 down, subtract 1 from -1, I get negative u, in this case is x plus 15 to the -2 power, times the derivative of what's inside, derivative of x plus 15 is also 1. So if I clean this up, I got 1/2 x plus 1 to the -1/2 times this function, don't forget that, x plus 15 to the -1, and then plus, well, this negative here, -1, I can bring out, making this positive a negative, x plus 1 to the 1/2, and then the x plus 15 now to the -2. So this is the derivative, but to clean it up, I think they ask you to leave it in fraction form. Think back to when I asked you to do the factoring that arises in calculus. We did several of these at the beginning of the semester, and the reason was because we encounter it, and the year we're encountering it, it's going to show up. I'm going to factor out the GCF. Now the GCF for the x plus 1s, we pull out the smaller exponent. What's smaller? -1/2 or 1/2? Answer, -1/2. X plus 15, I'm going to pull out the -2. Okay. The coefficient, I have a 1/2 fraction and a 1 here. You might say, well, there's no common factor. I'm actually going to pull out a 1/2. So and I'll show you why, because I want to leave no fractions. You say, how can you pull 1/2 out of 1? Well, you can. 1/2 times 2 is 1, but we'll show that in a minute. So I'm going to pull out a GCF of 1/2, x plus 1 to the -1/2, that's the smaller power, x plus 15 to the -2 smaller power. Okay, so factor this expression out of these two terms, right? Because I've got all this minus all this. So I factor out the 1/2, x plus 1 to the -1, x plus 5, x plus 15 rather, to the -2. And what's left here? Well, the 1/2 comes out. The x plus 1 to the -1/2 comes out. Now, what happens here? How do I do this? How do I factor out x plus 15 to the -2 from x plus 15 to the -1? Well, remember, when I multiply this back through, I'm going to have x plus 15 to what power here? Well, when we multiply like bases, what do we do with these exponents? This -2 and the exponent here, we're going to add together, right? -2 plus this will give me -1. So -2 plus what? 1 equals -1. So this is 1. That's the exponent here. That's what's left. Right, if I multiply this back through, I'm going to get this term. Now, from this term, of course, I'm factoring out the 1/2. You say, how can I do that? Well, answer 2, right? 1/2. What's 1/2 times 2? It's 1, right? So I have the minus sign here. And then I'm pulling out of x plus 1 to the negative 1/2. I have x plus 1 to the positive 1/2. So again, the exponent here has to be 1 because when I multiply, I'm going to add the exponents. Negative 1/2 plus 1 will give me 1/2. And of course, the x plus 15 to the negative 2 has been completely pulled out here. And so all I'm left with is these. So notice here, there's no fractions, no exponents that are negative. I can simply simplify. All right, x plus 15, distribute this negative 2x minus 2, and then 15 minus 2 is 13. X minus 2x is negative 1x. So I get 13 minus x for in here. And now I can rewrite without negative exponents because x plus 1 to the negative 1/2 is 1 divided by x plus 1 to the 1/2. This is 1 divided by x plus 15 to the second power. Of course, I got 1 divided by 2 here. So the 2, this thing are all in the denominator. And this, of course, is in the numerator. So here it is. Now I can clean this up a little bit if we note that the 1/2 power is the same thing as the square root. I think either of these forms will be fine. Okay. So that's the simplified result. You do have to go through this factoring phase to get there. Alternatively, you don't have to use this factoring out technique. You can rewrite at this point, like this would be x plus 1 to the 1/2 divided by x plus 15 squared. So you'd have x plus 15 squared in the denominator. And here you'd have to bring these both down with the 2, right? So you'd have 1 divided by 2, x plus 1 to the 1/2, x plus 15. And then you can subtract these two fractions by finding a common denominator, finding the least common denominator. And when you find that least common denominator, then you can subtract and simplify. But when you do so, you're going to get the same thing. So if you do it that way, that's fine as well. Let me show you how to do it with the quotient rule. Some of you might have tried it that way. If we straight up use the quotient rule without rewriting, we take what? The derivative of the top. And we've already done that, right? By the chain rule, that's 1/2 x plus 1 to the negative 1/2 times 1. We already did that in the previous problem. Times the bottom function minus the top times the derivative of the bottom function, but the derivative of x plus 15 is just 1. All over the bottom function squared. So that's the quotient rule. So if I simplify, I've got 1/2 x plus 1 to the negative 1/2 times x plus 15 minus 1 times that is just x plus 1 to the 1/2. Again, all over x plus 15 squared. Now I'm going to do this, but now the same thing. You could again, you could rewrite this as fractions and find the common least common denominator and subtract them. I'm just going to factor out the GCF. Again, I'm going to factor out a 1/2, kind of what I did before with the other example, times x plus 1 to the negative 1/2. And when I do so, that's going to leave me x plus 15 minus 2, right? The 1/2 times 2 gives me the negative 1. And then notice I need x plus 1 because the negative 1/2 exponent added to the 1 will give me the 1/2 exponent. And again, this should look familiar. If I distribute the negative 2, combine like terms, I get 13 minus x. And then all I need to do is this 1/2, the 2 comes down below, and x plus 1 to the negative 1/2 is 1 over x plus 1 to the 1/2. The 13 minus x is up top. Of course, the x plus 15 squared is down below. It's the same answer that we got previously. Okay, so either method will work. And you might say, oh, I like the quotient rule better. That's fine. But the problem is, again, you're getting to this expression, being able to simplify it a little bit trickier. Actually, if you rewrite this, it's exactly this expression right here is actually exactly what you have right here, essentially. Okay, simplified. So basically the same thing. Okay, if you've got questions about this one, that come make an appointment with me, email me, do something. Hope this helps with this one.